Hi student, now we will discuss about a freezing point depression constant. This belongs to solution chapter. This is also called as molal depression constant, also called as molal depression constant and also called as cryoscopic constant. Okay, what is molal depression constant or cryoscopic constant or freezing point to depression constant? For that, first we should know what is freezing point. If you take water, this will be freeze at 0 degree centigrade. That means it will convert from liquid to solid at 0 degrees centigrade temperature. This 0 degrees is called freezing point of that solvent, water. Here water na, so 0 degrees is the freezing point of that water. Suppose if you add to this water solute, to this water, then freezing point of this solution, this is the solvent, this is the solute, so this is solution. Okay, if you add solute to this solvent water, then freezing point of this solution or freezing point of that solvent will be decrease. Freezing point of that solvent will be decrease. That means less than 0 degrees this freezing point will be there. So this decrease in freezing point of that solvent is called depression in freezing point. Depression means decreasing in freezing point. Actual pure solvent, if you take pure solvent, that pure water that has freezing point 0 degree centigrade, suppose if you add solute like sodium chloride or any solute, if you add, then freezing point of that water, that pure solvent will be decreased. That means less than 0 degrees it gets the freezing point, less than 0 degrees centigrade. This decrease in freezing point is called depression. Depression in freezing point. Depression in freezing point. This is indicated by delta TF. F means freezing point, T means temperature. Delta TF means difference between freezing point of pure solvent and freezing point of solvent when we add, after we add the solute. That is the delta TF. Simply delta TF means difference between freezing point between these two. That is the depression of freezing point or depression in freezing point. This is the depression in freezing point. This depression in freezing point is proportional to molality of this solution. Molality. What is molality? Number of moles of solute present in 1 kg of solvent. What is molality? Number of moles of solute per kg solvent. That is the molality. Suppose number of moles of solute present in 1 liter solution, that is the molarity, capital M. Here small m means molality. This is the molality. So simply, if you add more solute particles or more solute to this solvent, depression in freezing point also will be increased. That is the delta TF is proportional to small m. If you remove this proportional, then we will get proportionality constant. Delta TF is equal to some proportionality constant Kf into molality small m. This Kf is called cryoscopic constant, or already we discussed now, freezing point depression constant or molal depression constant or cryoscopic constant. This Kf is called cryoscopic constant. How we can define this cryoscopic constant? If you take m equal to 1, then delta TF is equal to Kf into 1. That's Kf. That is Kf. Okay, here we discuss that definition. Delta TF equal to Kf into 1, that is Kf. So what is this cryoscopic constant? Simply delta TF. If you take one molal solution, then depression in freezing point is called cryoscopic constant or freezing point depression constant. So how you can define? If you dissolve the depression in freezing point when 1 mole of solute is added to 1 kg of solvent, the depression in freezing point when 1 mole of solute is added to 1 kg of solvent is called cryoscopic constant. Okay, I think you understand this definition. You see, if you take m equal to 1, this is the equation of delta TF equal to Kf into m. If m equal to 1, then delta TF is equal to Kf into 1, that is Kf. That means if you take 1 molal solution, that means the depression in freezing point when 1 mole of solute is added to 1 kg of solvent, this means 1 molal solution, this means, okay, is called cryoscopic constant or freezing point depression constant. Okay, na? Freezing point depression constant or molal depression constant or cryoscopic, all are same. In this, simply you have to understand, if you take pure solvent, it has some freezing point. If you add solute to that solvent, then freezing point will be decrease. That decrease in freezing point is called depression in freezing point. This depression in freezing point is proportional to molality. That means number of moles of solute in that solvent. If that number of moles of solute is increased in that solvent, depression also increase in freezing point. Depression in freezing point also will increase. that is the delta TF is proportional to m. That means suppose if you take 1 mole sodium chloride in H2O, suppose this is the water, pure water, this is the water plus suppose sodium chloride solute, and if you take another example, water plus sodium chloride. Suppose if you increase the solute particles, sodium chloride particles here, from here to here, if you increase the sodium chloride particles, depression in freezing point also will be increased. That is the meaning, is simply. Okay, so if you remove this proportional, then we will get proportionality constant, that Kf. Simply this Kf is called freezing point depression constant or molal depression constant, cryoscopic constant. How you can define this? If you take m equal to 1, then we can define this Kf, cryoscopic constant. M equal to 1 means 1 molal solution. 1 molal solution means 1 mole solute present in 1 kg of solvent. Then depression in freezing point is called simply cryoscopic constant. That I have written here. That definition I have written here. Okay, bye.